One of the big news items recently was the discovery of a planet that may end up being the closest planet to us in our own solar system, Proxima b.
Just when we thought the James Webb Space Telescope had shown us everything from the birth of distant galaxies to the death of ancient stars, it turned its golden mirrors towards something much closer, our stellar neighbor, Proxima Centauri. And orbiting this small, faint red star is one of the most intriguing worlds ever discovered, Proxima b. Now, for the very first time, Webb has delivered the clearest image of this alien planet, and what it reveals could change everything we know about the search for life. Proxima Centauri is the closest star to our Sun, sitting just 4.24 light-years away in the Alpha Centauri system. Unlike our bright yellow Sun, Proxima is a red dwarf star, faint and cool, invisible to the naked eye without a telescope. But what makes Proxima so fascinating isn't the star itself. It's the planet orbiting around it. In 2016, astronomers announced the discovery of Proxima b, an Earth-sized planet located in the star's habitable zone, the region where liquid water could exist on its surface. The news electrified the scientific community and the public alike. For the first time, we had found a world that might be not just Earth-like, but close enough to study in detail. Despite being our closest exoplanet neighbor, Proxima b has been nearly impossible to see directly.
Why?
Because it is small, rocky, and orbiting very close to its dim star. From Earth's perspective, the glare of Proxima Centauri has always overwhelmed attempts to capture the planet. Astronomers have studied Proxima b indirectly through the star's wobble and through faint dips in starlight, but we never had a clear direct image. The planet remained a mystery hidden in the shadows until now. With its infrared vision, stability in deep space, and massive golden mirrors, Webb is uniquely equipped to block out the star's light and directly image nearby exoplanets. After months of calibration and testing, scientists finally pointed Webb toward Proxima Centauri, holding their breath for what it might reveal. And Webb delivered. For the first time, astronomers now have the clearest, sharpest image of Proxima b ever taken. And it's more than just a dot of light. Webb's instruments have captured enough detail to reveal hints of the planet's atmosphere, surface features, and even possible cloud systems. The image itself is stunning. Against a black canvas of space, Proxima b appears as a glowing Earth-like orb, bluish in some wavelengths, reddish in others. Webb's infrared sensors show temperature differences across the planet, suggesting that one side is hotter than the other, exactly what we'd expect from a planet locked in a tight orbit around a red dwarf star. But what caught scientists' attention was not just the shape, but the subtle signs in the light spectrum, traces that may hint at something truly remarkable, an atmosphere capable of supporting life. When the James Webb Space Telescope released its first clear image of Proxima b, the scientific world was not just excited, it was stunned. For the very first time, we weren't just looking at a faint signal hidden in noise. We were looking at a real planet orbiting the star closest to our Sun. And Webb didn't stop at just an image. It revealed details that could change the way we think about life in the universe. One of the first questions astronomers had was simple. Does Proxima b have an atmosphere? Planets orbiting close to red dwarf stars often suffer from powerful solar flares which can strip away their atmospheres over millions of years. Many feared that Proxima b was a barren, airless rock, scorched on one side, frozen on the other. But Webb's instruments detected spectral signatures, faint fingerprints of light passing through gases, suggesting that Proxima b might still have a thin atmosphere. Early analysis points to traces of carbon dioxide, water vapor, and possibly methane. These gases are critical because they could regulate temperature and even hint at biological processes. If this is confirmed, it would mean that Proxima b is not just another rock, but a dynamic, evolving world. Another surprising revelation was Proxima b's temperature profile. Webb measured thermal emissions from the planet's surface. The data showed a strong contrast between the day side and the night side. This suggests that Proxima b is tidally locked, one side always facing its star in perpetual daylight, the other in eternal night. While this may sound extreme, computer models suggest a thin atmosphere could redistribute heat, creating a twilight zone along the boundary between night and day. And this twilight region, scientists argue, could be the most likely place for liquid water and possibly life. Webb's infrared imaging didn't just stop at temperature. It revealed subtle color variations across Proxima b's surface. While not sharp enough to see continents or oceans, these variations suggest differences in reflectivity. Some scientists think this could mean surface ice caps, rocky deserts, or even liquid water seas. Others caution that it may simply be differences in rock and mineral composition. Still, the fact that Webb can even detect such differences from over 4 light-years away is mind-blowing. Of course, the biggest question remains: could Proxima b actually support life? With evidence of a possible atmosphere, potential liquid water regions, and stable temperatures in certain zones, the planet checks several boxes for habitability. But there are still challenges. Proxima Centauri is known for violent stellar flares capable of bathing Proxima b in deadly radiation. If the planet's magnetic field is weak, it may not protect its atmosphere or surface. However, Webb's readings suggest at least some protection may still exist. If confirmed, this would make Proxima be the most promising nearby candidate for habitability we've ever seen. Perhaps the most exciting part of Webb's discovery is what it means for the future. Proxima is so close, just over 4 light-years away, that it's often considered the first realistic destination for interstellar travel. Projects like Breakthrough Starshot envision sending tiny laser-powered spacecraft to Proxima Centauri within a few decades. Now, with Webb's image and data, we may actually know what kind of world awaits us, a world that could, just maybe, host life. With the James Webb Space Telescope giving us our clearest look yet at Proxima b, the excitement around this mysterious world has never been greater. But this image is just the beginning. What comes next may decide whether Proxima b becomes the first alien world humanity truly understands or even one day visits. The next step for astronomers is to search for biosignatures, chemical fingerprints that could suggest life. These include gases like oxygen, ozone, methane, and nitrous oxide in unusual combinations. On Earth, life itself maintains this delicate balance. Without biology, our atmosphere would look very different. If Webb or future telescopes detect such a balance on Proxima b, it could be the first real evidence of alien biology beyond our solar system. Already, hints of methane and water vapor excite scientists. If these can be confirmed and paired with oxygen, it would be groundbreaking, perhaps the most important discovery in human history. But Proxima b is not without danger. Its star, Proxima Centauri, is a flare star known for releasing bursts of radiation that could sterilize unprotected planets. Webb's data suggests that while Proxima b may have some atmospheric protection, the long-term stability of life there is uncertain. Still, some researchers argue life could adapt underground, beneath oceans, or within protective layers of ice. On Earth, life thrives in the harshest places, from boiling hydrothermal vents to the frozen Antarctic desert. If life can survive here, why not there? With Proxima b being the closest exoplanet, it has become the ultimate target for future exploration. Several mission concepts are already on the drawing board. Breakthrough Starshot is a plan to send fleets of tiny light-powered spacecraft racing towards Proxima Centauri at 20% the speed of light, with a travel time of just over 20 years. These probes could beam back real images of Proxima b's surface. Next-generation telescope projects, like the Habitable Worlds Observatory or massive ground-based telescopes, could resolve Proxima b's atmosphere with even more detail. Interstellar probes, though still science fiction, are being seriously considered by scientists developing the technology needed for a crewed mission to the nearest stars. If humanity ever ventures beyond the solar system, Proxima b will almost certainly be the first destination. The importance of Webb's image goes beyond astronomy.